Hello guys, welcome to another video. In this video we will see on how we can create multi-agent, and inside which we will have a supervisor agent, and that supervisor agent will decide which agent to call. In the previous video we just called the agents one by one sequentially. Here we will have a supervisor agent. The purpose of that supervisor agent is it decides which agent to call, and we do this using LangChain and Ollama, and inside Ollama we are using the Llama 3.2 model. So I'm just declaring the Taveli API key in the environmental variables because I use this for an internet search, and now I'm just importing the required libraries. That's it. So I'm just having one tool, Taveli search results. This is the class from Taveli. So we can just do like Taveli tool dot invoke of and ask whatever the question, and it literally works like a Google search. And here I'm just declaring the class named agent state, and inside which the variable next. And I am inheriting the messages state. The purpose of inheriting the message state is we can access the messages inside any node at any point in time, and also this variable can be accessed at any point in time. That's the purpose of declaring the variables here, and this class will be tagged to our workflow. And also if you see there are two particular agents here, research and validator, apart from the supervisor agent, and once it is done it has to go to the finish. So we are just giving a prompt to our supervisor agent. So you are a supervisor task managed and conversation between the following workers. So it has to decide which agent to go based on the user code. That's the prompt we have given here. And I have declared a class which is of type, and I am inheriting the type dict because inside this next we are passing all these strings like researcher, validator or finish. All these things. This next will hold any of these three values only, and the purpose of this class is we are binding this class to the supervisor agent inside the LLM used inside the supervisor agent. If you see, I'm just importing the chart Ollama from LangChain Ollama, and this is our LLM which we are going to use throughout. And this is where I'm creating supervisor node, and I'm just having one argument state of type agent state, and the purpose of this state is so to access either the messages because we inherited the message state, or else to access this variable called next, because this next variable holds any of these values, and the supervisor agent should direct which node to trigger or which agent to trigger based on the user ask. Now I'm just creating a message with the system prompt which we have created above for the supervisor, this one, and that's it. So I'm binding this particular router to the LLM so that the supervisor agents will decide which agent to call next. This router has this particular variable called next which holds these values: researcher, validator and finish. That's it. And now we are just saying, like, in case if the next is equal to finish, then go to the end. That's it. If not, just return what is the next. So the next can be either validator or can be the researcher. So I'm just creating an agent here. We have a class called create react agent in LangGraph, using which we can create the agents. So you have to just pass the LLM, which is our chart Ollama, and just passing the Taveli tool here. And you are a researcher who receives search results. That's it, I'm saying. And this is an agent. I'm just creating a node with that agent. So dot invoke of state. So we are just passing the full information to this particular agent using this state variable, and state variable is nothing is of type agent state. That's it. And we are just returning the messages. That too we are just returning the last message alone. And we have another tool. So the purpose of this tool is it will just validate whether the information is relevant or not. That's it. And we are using the same Ollama LLM here and binding with this particular class, and the purpose of binding with this particular class is so it will just return a string called relevant or not relevant. That's it. And now I'm just creating a system message and just guide this particular model, and I'm giving the user input, the content and the topic which comes from the parameters of this method or a tool. That's it. I'm just invoking and it just returns that particular response. So with this particular method or a tool is passed to the agent. If you see, we are again using the same class create react agent, LLM and the tool, and just a prompt and what is the purpose of this particular agent. That's it. And we are creating another node here, and in that node we are just using this validate agent and invoking based on the state. So this particular state will have the information at that point in time because it is of type agent state. And what is agent state? As we have seen already, agent state is nothing but a class which inherited the messages state and the next. So agent state will have two variables. One is next, and the next is the messages at any point in time. The messages we are getting by appending in each and every tool. So inside each and every node we are just returning the messages, and the content of this message is nothing but what this particular agent has returned. That's it. So we are just reading from the result dot the last message dot content. Similarly here as well, same. That's it. So now we know we create a graph in LangGraph. So we are using state graph class, and inside which you are passing the agent state. And now we are just adding an edge. After start, go to the supervisor, and then we are adding the required nodes. One is supervisor node, one is researcher node, one is validator node. And then if you see here, using the members, inside this members list, we will have the supervisor and validator. If you see above, we have declared here. So we are just creating the edges here. That means after supervisor, go to, that means after researcher, go to supervisor, and again after validator, go to supervisor. That's what we are saying. So again we are saying after supervisor, whatever the next value is returned from the state, if you see the state, and whatever the value holds in this variable, go to that particular agent. That's the conditional edge we have given here. That's it. And we are saying after start, come to supervisor, and just we are just compiling that particular graph. If you see, this is how the graph will be: supervisor, researcher, and validator. Now I am asking gather the information of 2611 in Mumbai, India. So it first decided to go to the researcher.